Greetings all, this is Sean from Boost Tutorship, and today I'm going to show you how to do Lab 1 for CAO. First off, let's start our CPU scene. Now we're going to close this file and then open a new text file. And we're going to save everything according to this format. Make sure that your text file ends with .a, whereas your system file or machine file ends with .cpu. That way it will function when other people open up your text. Now for the first part, we will copy the assembly code into our text file. Here you will see that the syntax is slightly incorrect, so correct it as you see it. Okay, once we've done that, we will go to the first part of the actual assignment. So first of all, we see here is 3 opcodes, namely load, store, and multiply. There's a secret fourth one, which is stop, which you have to leave as well, because without it, there will be an execution error. So we will change the opcode according to these. 1 being load, 2 being store, and 3 being multiply. We will delete the rest as they aren't used in this exercise. And that is the first part done. So the second part states that the length of the main memory is 2048 with cell size of 16 bits. So you have to go to your hardware modules and modify it according to the requirements. Okay, now that that's done, we will now look at this. The basic instruction execution cycle consists of 2 sub-cycles, which are fetch and execute cycles. During fetch cycles, the following tasks are conducted. Copy the content of PC into MAL. Fetch the content of memory cell where the address is stored in MAI into MBR. Copy the content of MBR into IR. Increment PC by 1 and decode IR. So this basically states what needs to happen in the execute sequence or fetch sequence, which is also in here. So we can see PC to MAR, PC to MAR, MAR into MDR, because we haven't changed it yet. We're supposed to change it into MBR, but you can see it's about the same. MBR into IR, which is the same. PC by 1. Now, there's a discrepancy here. Increment PC by 1, but here is 2, so we have to change that. So first we change the name from increment 2 to increment 1, then we change the delta to 1. Okay, now that's done. We match, it will be matching. And finally decode IR, which is okay. So we've done this part as well. Now we do this part, which is optional, but required in this exercise. It won't actually change how your program functions, but since the assignment requests us to do it, we will do it. So first we go to hardware modules, then rename our ACC to AC, then our MDR, MDR. And then we have to rename all our micro instructions as well. So go here, change every ACC to AC and every MDR into MBR. Okay, now that that's done, we'll move on to the next part, which is to run our program. So for this, we would like to change the registers to decimal, and then we would like to change the row size here to 1. That way, when we execute and then assemble and load, we can see the opcode here. It has to match the opcode given here. So load has to be 0001, which can be seen here. Load is 0001. Store will have to be 0010, which is here, 0010. Multiply has to be 0011. 0011. So once you confirm that your old code is correct, it's time to run your program. Here you can see the result is stored in the AC. So there's no output for this assignment, as we do not use the write command. We only store it in the AC. And with that, your assignment is complete. So after you save the text file and the machine file, you have to upload them both into ITEL like so. So in here you can see this is my assembly file, that one my matrix number, and then .a, and this is my machine file, that one machine number.cpu. So with that, you have successfully completed your lab. This has been Chan from Boost Tutorship, and from Spark to Success, we boost you.